So after the selection approach, selection scheme, selection step, what we are going to do is actually selecting two solutions. We want to select two solutions and we want to cross over. Crossover usually happens in the DNA. So imagine that we have two DNA sequences from two persons. And then what happens is that they twist over and they share somehow the mixed DNA. And from this mixed DNA, you can just choose one or two, and then these two or these two will create another human being. So this is from your father, and this is coming from your mother, and it twists over, and somehow you are being selected. So that's you, sons and daughters. Okay. So selection step, we find two solutions to be the parent of a new solution. So the new solution is going to be generated by mixing of some genes of two solutions. Means that if we select 0, 1, 2 and 1, 0, 2, we are going to mix somehow. We are going to mix somehow, and we are going to create one new solutions from this mix. So this mix-up is going to be called crossover. So the best case scenario is that the new solution takes only the best parts of the two solutions. So if a certain route part is better at traveling, and if a certain route is better at traveling, and we want to combine it. So, for example, we just add up these two cases, for example, and we come up with 201. And if this is a better value, then it's going to be the success. But the worst case is, what if we cross over the worst part of the two solutions? For example, this was something that was not very good at routing, a small part. This was not such a good idea in terms of routing from this genotype. And then we mix it over, and if we create the 0, 1, 2, and then we are not that successful in creating a new solution. So we want to have this best case scenario, but sometimes our crossover creates a not such a good idea in terms of the quality of the solutions, so we have to be careful about. So hence we need a good crossover. There is an interesting story here. So George Bernard Shaw, have you ever heard about the George Bernard Shaw? So actually he is a playwright. Playwright, if you don't know, is kooc.kaist, and the co-founder of London School of Economics. So he is a very intelligent person. And Isadora Duncan is the creation of the modern dance. Actually, those two were close, and those two corresponded through mails, like letters. So Isadora Duncan says that, think of it is that with your brains and my body, what a wonder it would be. It means that if we get married and make a sons and daughters, and that if those sons and daughters have your brain and my body, then it's going to be a very wonderful person. So it means that it's taking only the best scenario of the two genotypes. And the George Bernard Shaw responded to her, then she stopped for a moment and replied, yes, but what if it had my body and your brain? Okay, so obviously, right, you see the point. Okay, so crossover. One type of crossover is multi-point crossover. It's being called multi-point crossover. So for example, let's see that 1 point crossover here. Select a position over a genotype. You pick a certain position in the genotype, a certain position, crossover position, and you choose the parts alternatively. So you just have a one part coming here, and alternatively means the otherwise. You take the other part after this crossover point. And then this solution is going to come here, and alternatively, this solution is going to come here. It's very simple, right? And I believe that you can create this crossover step function implementations with simple for loops. It's 1 point crossover. But of course, we can set up the multiple points and set up the multiple points positions to cross over, and same thing, choose the parts alternatively. So we set up crossover parts here, crossover parts here. So we take 2, 3 here, and then this solution comes here, and then alternatively this solution comes here. Similarly, this 1, 2, 1, 2 here, port 7, 8, 9, port 7, 8, 9 here, 7, 8, 3, 7, 8, 3 here. So this multi-point crossover actually is very interesting and very easy. But there is a big problem, which is being called the inconsistency problem. So imagine this. We did this crossover, and this new solution here, it has now 2 8s, and it has 2 9s. It has 2 3s. That's bad. It has 2 5s. That's really bad. It has 2 1s. So this solution is really not working. It's originally 1, 2, 3, 4, 5, 6, 7, 8, 9. It successfully traveled 9 cities. But these solutions, it omits, it doesn't visit 3, 7, and 8. So that's going to be a problem. Similar problem happens here. 5 happens here 2 times, 6 happens here 2 times. Means that it is missing something. Of course, this is not visiting 7 and 8. 7 and 8 should be somewhere here, but it's gone, right? So that's bad. So might not produce a valid solution, valid travel route. There are 2 styles here. Produce and repair means that you just make all the crossover and make a whole new solutions, and you only choose the solutions that are valid. And then because you don't have enough solutions to fill in the population, and then you keep doing the crossovers by selecting different points. You keep doing that. That's the produce and repair approach. And the other approach is the careful crossover. You being careful in making a valid solution, and your crossover always gives you the valid route. Of course, the multi-point crossover is not this approach. It's rather this approach. Okay? And there are other cases. It's being called arithmetic crossover. So we are dealing with traveling salesman problem, and all our values are categorical values. What it means that actually we are dealing Seoul, Gwangju, Daejeon, Daegu, and Busan, right, and Gangneung. These are all categories, and the numbers that we are seeing is that just 0, 1, 2, 3, 4, 5, which are categorical values, even though they are numbers. But what if we are dealing with the real numbers, real floating values, double values? In that case, categorical values are not appropriate to apply this particular crossover scheme. But real values can take advantage of using some numeric operators in the crossover. For example, you can find the arithmetic mean of those two, or geometric mean of those two, or harmonic mean of those two. You have two parents, it has these values, and we can get a new solutions by using means. And mean, the average, there are very different types of average in mathematics. So it's not only one, which we often use arithmetic mean, but geometric mean and harmonic mean are also valid mean in some from certain perspectives. So you can utilize that approach. So pros, the gains, merits, advantages are using the right operator can be very successful in a numeric arithmetic crossover by utilizing the real values, real numbers in the genes and genotypes. So it's more flexible, so that you can create a new solutions. However, choosing a bad operator can be really devastating, means that very destroying. So too early premature conversions, or you are just making one more assumptions by setting up these operators. Yeah, you are making a whole bunch of the assumptions in here because you are using the heuristics. You don't want to add another assumptions here. But if you choose a certain operator, you are making that assumptions. If that assumptions is a really right assumptions, then it can be very successful, but actually many times it's very hard to find a right operator. Anyhow, this is about the real numbers, which is not categorical values, and it's not going to be covered by TSP, traveling salesman problem, so we are going to move on. Okay, so here this crossover, this crossover is being called the edge recombination crossover. So it's specialized crossover strategy for TSP. We have parent 1 and parent 2 here. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 2, 5, 0, 9, 7, 3, 8, 6, 1, 4. These are the solutions, right? And then what you're going to do with these tables, we are going to create another solutions here. But it's more optimized to the traveling salesman problem. How it works looks like this. So we obviously we have 10 cities. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 city. 9 means that we have 10 cities here. And then actually, if you just draw a diagram here, P1 solutions is going to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So P1 solutions looks like this. Traveling salesman travels from 0 to 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 0. That's the parent 1. Parent 2 is a little bit different. Parent 2 is going to, yeah, we have the other. So 2 to 5, right, like this, and 5 to 0, like this, and 0 to 9, like this, and 9 to 7, like this, and 7 to 3, like this, and 3 to 8, and 8 to 6, and 6 to 1, and 1 to 4. And then 4 to 2. Okay. So these are red ones are the P1 and the so blue ones are P2, parent 2. Okay. And then let's just write down all the links that each city has by considering those two cities at the same time. This we really want to have a different color here. Okay. So for example, this city 0 has a neighbor of what? City 9, city 1, and city 5. That's all the links are coming in and going out. So we have 9, 1, 5. And city 1 has a neighbor of 0, 0 here, and 2 here, and 4 here, and 6 here, 0, 2, 6, 4. And city 2 has 1, 3, 5, and 4. 1, 3, 5, and 4. So we keep doing that until we hit city 9. City 9 has 8, 7, 0. 8, 7, 0, right there. And then actually we can see some interesting pattern. I'm just gonna erase it a little bit. Oops. Yeah. Okay, pen again. Let's consider this case, right? So 9, 0. It has parent 1's directions, right? And the 1 goes to like this, right? And then the other solutions are 9, 0, and we have 5, and we are 8, and we have 7, right? This, and 1, and the 5. Okay. So that's actually what we are doing. So 8, 9, 0, 1. That's the from the parent 1, and what parent 2 comes in is that P2 from 7. From 5, it comes to 0. Like this, and from 0 it goes to 9, right? This, and from 9 it goes to 7, like this. Okay. Those two solutions shares a great value here. Those two solutions pointing out that this 9 to 0, 0 to 9, 9 to 0, this way, this route has really small value, and it wants to keep in its routing schedule, right? We can see that. And similarly, city 9, it has a certain sharing of that. Okay, city 0 and city 9 shares a single route that is being utilized by both parents. Okay. So in the I'd rather just keep using the pen. So if we just go through these cities, most of cases it has 4 links, because that it has to come in and go out means that one solution has 2 links. And because we have 2 parents, we have 4 possible links. And these 4 possible links are listed like this. However, if some links are shared, or if some links are shared like this, if those links are shared, it can reduce the value like this, 3 values or 3 values. If the links are perfectly matched, in that case, we only have 2 rings for each city. So maximum 4 rings, minimum 2 rings. Why is that? Because cities have to go in and go out. It means that 2 rings at least for a single solution. And because we have 2 solutions as parents, we can have maximum 4 rings. Having said that, if those rings are matched up, then it is going to be just 2 rings. Okay. Then this edge recombination crossover works like this. Starts from either the first city of a parent solution, for example, the city 0, or the city with the minimum number of the neighbor cities. Here, again, city 0, here as well. And we just select city 0 as our first city to visit in our new solutions. And then traverse through the cities with the minimum number of the neighbor cities. So we have 9, 1, 5 as our neighboring cities. 9 has 3 rings, 3 neighbors, and 1 has 4 neighbors, and 5 has 4 neighbors. Means that it's better to get to the link city 9. And so we go to the city 9. And then 0 is already visited, so it's gone. 8 has 4 links. 7 has 4 links. So it's going to be a coin toss, and it's going to be either 8 or 0. And then keep going up. Why we choose the minimum number of the neighboring cities? Because that those cities actually have some agreements in terms of the neighboring cities in the parent solutions. That's why we keep choosing the minimum number of cities with the minimum number of neighboring cities. Okay. So by following this minimum, we just go to 0, 9, and 8 or 7 and other places. And now you can see that 0 and 9 are placed together because at the parents, they share this this schedule in terms of the solutions. Okay, that's our edge recombination crossover. Having said that, this edge recombination crossover is really different from the multi-point crossover. Multi-point crossover made various invalid solutions. In that case, yes, you have to produce and repair approach. You have to perform produce and repair like this. But this crossover is very well designed or like carefully designed so that it doesn't produce any invalid solutions. So it means that you don't have to spend so much time in reproducing a valid solution.